test I take, I get an A. Yeah, screaming that's none. When I pulled out the lock, that's done. Doing my thing, homework all day, every day. Triggers is it, triggers is it, triggers is it, triggers is it. Seeing Mr. Ng's face during period 3. Triggers is it, triggers is it.
Hey math lovers, let's go over 1.73, solving a quadratic inequality by graphing. We're going dark mode. Alright, steps to solve quadratic inequalities. We're going to first solve it, so solve. Use your methods of solving, such as factoring, quadratic formula, and then number 2, go ahead and graph it. Graph. Number 3, you're going to find solutions. And here, you're just going to have test points. And then under test points, I want to talk about a couple of ways you can show your solutions. One way that you can show your solution is called set builder notation. Set builder notation. And basically set builder notation, this is a bracket, x, and what I want to show you about set builder notation is that you're just going to have, it's really an inequality, negative, I'm just making up some kind of answer here. That is one way of getting your answer, or you can also use interval notation. And interval notation takes the same numbers, let me just highlight those. I need numbers that are smaller than 2 and numbers that are bigger than -3. So basically you're going from -3 to 2, and that is not a order pair, it's an interval notation. Okay, so let's go ahead and try number 13. And number 13, let's go ahead and solve this. The easiest way of solving is hopefully going by factoring. So let's see if we can factor this one here. ax squared plus bx plus c. I got my a times c, which is 9. B value is -6. Okay, my two numbers are going to be -3 and -3. And if you remember now, the trick is that you don't need to use the box when a is equal to 1. You only factor. You could use a box and you'll get the same answer, but it's not needed. I'll just show you really quickly. Take greatest common factor, greatest common factor, greatest common factor, greatest common factor. Okay, so we're factoring this to be x minus 3. X minus 3 is less than or equal to 0. Okay, at this point, all you need to do is just, so what have we done so far? We're solving. And forget the inequality sign, just pretend it's an equal sign, and let's just set them both equal to 0. And when you solve it, you'll get x equals 3. Okay, so if I put a dot here at x equals 3, I have the y-intercept at 9, 3, 6, something like that. And I'm going to put a, whoops, too thick. There's my axis of symmetry. And why do I know that is because it's actually in vertex mode. I'll show you in a second. So this is what my parabola kind of looks like. Now, how did I know that? If you went a couple steps further, you would have gotten x minus 3 squared. And then if you put a plus 0 here, you would have recognized, let me put it in that form, it says it's saving image. A times x minus h squared plus k, and then we would have seen that the h is 3k is 0, which is right there. 3, 0 is my vertex. Okay, so what we've done so far is we've solved it and we graphed it. Now we're going to get some kind of solutions. So what I'm going to do here is I'm going to point this out. I'm going to test 2, I want to test 3, and I want to test 4. Okay, and you can use the original equation. X squared minus 6x plus 9 is less than or equal to 0. So let's test 2. So I get 4 minus 12 plus 9, and then I will get, actually that's not an equal sign. We're testing the inequality, so negative 8 plus 9 is 1. Is 1 smaller than 0? That is false. Okay, so what we're doing here is we're creating a not a shaded region, but a solution on the x number line. Okay, let's go ahead and try 3. So that would be 9 minus 18 plus 9, and you'll get negative 9 plus 9, which is 0, and this is true. So this is a solution, and that's why I have that blue dot there. And let's go ahead and try the last one, which we said we were going to test 4. 4 squared minus 6 times 4 plus 9 less than or equal to 0. And that would be 16 minus 24 plus 9. So that would be negative 8 plus 9 is 1 is less than or equal to 0, and that is false. Okay, so that 4 and anything over here would be false, and the only thing that was true is actually just that dot right there. What does this mean? It means that 3 is our solution. So how do I write that? In set builder notation, you're going to draw that bracket. It looks kind of cool. All values of x such that only x is equal to 3. Okay, and to write that in interval notation, I guess you could just write the only thing that you're going to include is 3, bracket 3, and you go to 3, and that's the only number you can pick. 3 is the only solution. Let's box that as our answer. All right, let's try number 16. Let's do the same thing. Let's see if we can solve this. And I'm going to factor it. A times c is negative 6. My b value is negative 1. And my two numbers have to be 3 and 2. And I want those to add to be negative 1, so that'll be negative 3, negative 2. So I get two equations, x minus 3 and x plus 2. Remember, the inequality sign you get intimidated by, just don't touch it for now. You're going to get x equals 3 and x equals negative 2. Okay, what we've done so far is we've just solved. So let's go ahead and put that on our, and let's get some other pieces that we might know. My C value is -6. -6. Okay, so the midway point between those two, if you add -2 plus 3, -2 plus 3, you'll get 1, and then 1 divided by 2 is 0.5. Okay, so what I'm trying to point out to you guys is on your x-intercepts, those two values, if you cut it in half, that is actually our vertex. Okay, and you can just put in 1/2. Again, how did I find that? Let me write that out. It's not a shortcut, but in factored form, which we just have right there up here that I'm highlighting in pink is factored form, they also call these P's and Q's, and so if you do P plus Q divided by 2, this is going to get your axis of symmetry. So that is the advantage of factored form. So again, if you add those two values together, you'll get 1/2. X equals 1/2 is our axis of symmetry, and that was the dotted line. Now, if I really want to find out where the other half is, I can just put it into the formula or the equation. So 1/2 squared minus 1/2 minus 6. This will give me 1/4 minus 1/2 minus 6. And I want to clear the fraction, or I can just multiply here. So it seems like the lowest common denominator is 4. So 1/4 minus 2 over 4 minus 24 over 4, because 24 over 4 is 6, -6. And so essentially you can do 1 minus 2 minus 24 over 4. So that's -1, -25 over 4. And if you put that into your calculator, -6.25. So what did I just find here? I just found the vertex. You could have put that into your calculator, but I did it by hand. Which means that x and y, that means here is my vertex. So when I graph this, okay, we solved it, we graphed it, and now I'm going to use some test points. Let's change colors here. Okay, the test points that I'm going to pick are, let's pick 0, because that's the easiest one, to the left of it, so -3, and we'll pick to the right. So I'm basically picking to the left of the parabola, in between, and then to the right, okay? So let's test each one of those. So let's go ahead and put in -3. Now this time you are comparing it to the inequality to figure out where it's true and false. You are comparing it. The previous one I did not, just because I'm trying to find a vertex, an order pair, x's and y's. This one I'm now comparing to the inequality. So I get 9 plus 3 minus 6. You get 12 minus 6 is 6. And 6 is less than 0. This is false. So the area that has -3, you can write x or you can write no. Okay? Let's try 0. So 0 minus 0 minus 6. -6 is less than 0. This is true. Saving image. Okay, so. Okay, what does this mean? our solutions on the number line on the x-axis when we graph it will be in between the parabola, and let's just double check that 4 would be false. 16 minus 4 minus, we don't need that, 6. So 12, you'll get 6 is less than 0, which is false. Okay, that means this region over here is false. Okay, so let's clarify what we're doing right here, right now. My solutions for the solution, let's see if I can make this super thick, and let's use a color I've never used before. Let's use purple. So my solutions are going to be here in purple. Okay, so what numbers is that? That was -2 and 3 there in blue. So you can do -2 to 3. And it is a closed circle because I have the original problem has an equal sign. So for interval notation, we can just have a bracket, -2 comma to 3. What does that mean? You can pick any number between -2 and 3. You can include -2 or 3, substitute it in here, and we'll get a number that is less than 0. Okay? That means if you picked a different number, like what we did, -3 or +4, you put it into the quadratic equation and it would be false. How would I write this in set builder notation? You basically use the same thing that you have here. X, all values such as it's between, it is greater than -2. Now I'm reading that one right to left. X is greater than or equal to -2. I said right to left, that is right. And then this one is less than 3. And then you just close your bracket. So that is our solution for number 16, sorry.
Equals to solve and graph 2x squared plus 3x less than or equal to 20. I have a quadratic. I'm going to pretend the inequality sign is an equal sign. I'm going to subtract 20. 2x squared plus 3x minus 20 less than or equal to 0. Next thing I'm going to do is I'm going to take a shot at factoring. A times C is -40. B value is, remember, if you need hints, you can write out the factors of 40 on the side, larger number on the left. And that way you can kind of visually see which ones can you subtract or add and change the math operations. Which one, class? 8 and 5. Do I need to change any of those? Which one? -5. Okay. Common mistake is to make the binomials here x plus 8, x minus 5. The reason why that would be wrong is because x times x is x squared, not 2x squared. So you have to use the box. Okay, these go here. Class, what do I write? 8x and that one. -5x. What goes up there? 2x squared. And the last one, your C value always goes in the bottom right, -20. Class, can I put a 2x? Can I put a 2x over here? Oh, let's try something new. Let's just go that way. I just don't have space. Is the greatest common factor of this row 2x? What is it? Can I do it this way? Should, right? Let's try it. Greatest common factor here. How about over here? And over here. Plus I would have put this over here, but I ran out of space. We're okay? So 2x minus 5, x plus 4 is less than or equal to 0. Raise your hand if you factor it like that. Raise your hand if you got these factors. Okay, so if you did quadratic formula, then you would have gone R's, 0 product rule. 2x minus 5 equals 0, x plus 4 equals 0. Add 5, 2x equals 5, divide by 2, x equals 5 halves. Subtract 4, x equals negative 4. Raise your hand if you got this. Nice, good visual. No comment, I'm recording. So my x-intercepts here at negative 4, 2.5. Some other clues you should have gotten is a y-intercept of negative 20. And if you guys aren't picking up why I'm starting to give you guys all these details about graphing, because we actually haven't really graphed in specifics about quadratics, but eventually it will come. Maybe I count by 2s here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm counting by 2s. Class graph opens up or down? Up, because your A value is positive. Sketch. Remember the y-intercept here is not your minimum. Make sure it is a U. It's nice. Our teacher would be proud of me. And let's write down our test points. So I had negative 4 here. This is 2.5. Remember, we can test our test points by just using our graphing calculator, right? So I'm going to put that in. Go to y equals. I'm going to put in 2x squared plus 3x minus 20. Yesterday we learned about how you can use the table function. So second table, I can just put in some numbers here. So I'm going to test negative 5. I'll test 0. And I'll test, I don't know, 4. Is that your favorite number? Negative 5 is equal to 15. So if I put in negative 5 into the function, I get 15. Class is 15 smaller than or equal to 0. No, so this area is false. If I put in 0, I get negative 20. So if you can put in 0, right? 0, that all becomes 0, that becomes 0, so you have negative 20. So negative 20, is it less than 0? So, true. This whole region is true. And 4 gives me 24, that is 24 less than 0 is false. Okay, so old school, yours would have been like this, right, in purple. Open or close circles? Closed, right? And you would have done something like this. Yes? And then yesterday's lesson, we just said, well, these are not solutions. Anything to the left and to the right. It's in between. So the graph that's in between is actually your graph. These are the solutions in red. And then we can write in one rotation with this. Bracket or parentheses? Negative 4. My graph solutions all the way over to here, which is what? Bracket 2.5 or 5 halves. Raise your hand if you got that as your answer. So get your x-intercepts, give yourself a graph, use your test points, use your calculator.
We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today. Listen up and behave. We doing math today. We doing math today.